Welcome back, Math 8. Today we are going to continue our linear relationship, but now things are going to go to grade 8 level. So far we have done some of the review that you guys did in grade 7 time. That involved solving one-step and two-step equations, and how can we make a certain data set. So for example, you have a relationship is given, and then by putting some number like 1, 2, 3, those kind of thing, and then figure out what will be my output value, which is y values. Now today's goal is we are going to connect our real life problem like what you said in here. There's a Tony's Pizzeria, so there's some menu related, there's some rate related. We're gonna do some word problem. First thing first, this is not a brand new worksheet. You actually have it in the Duotang, Math Duotang page 8, by the way. So you can always double check from there. If you don't have anything, but you have a printer, it is available in Google Class, and at the same time you can also just choose to copy the problem in a blank pieces of paper, whatever the method that you can do. And of course, if you have printer, then it's easy, but if you don't have a printer, this is also not a big deal. There's not much a question anyway. So the question asks you, how can we know a relation as a linear relation? When you think about linear relation, there are two different possibilities. First thing is, you have any increasing pattern, or decreasing pattern. But increasing and decrease, these two have a constant number that is increasing and certain number that is decreasing. So it's the same amount. Let's go through one of the example that I put in my booklet, which is Tony's Pizzeria. Tony's Pizzeria sells medium pizzas for $9 each. You can order extra topping for $1 per topping. So there are two clues that is given, and which is also given on the right page over here. And you can create a table, and you are asked to create a graph at the end. So it does ask you a little bit more further, but still we're not looking for any type of equation part yet. Let's highlight some of the clue that you think is significant. Medium pizzas for $9. Extra topping 1 per topping. So as you may notice, we have two different type of values given. It is your job to figure out which one is a changing value. So what I mean by that is manipulative variable. In math and science, which in math is generally an X. And we are going to find out how much is a total cost, which is responding variable. In this case, we're talking about the total price of it. So, at least responding variable, we know how much it cost. Then let's see what kind of things are changing. Like for example, medium pizza, $9. We are not talking about, how can I say, the relationship of one pizza, two pizza. However, we're talking about this each extra topping. So topping, ladies and gentlemen, in this situation is manipulative variable. Manipulative variable is a fancy way of saying we can change some number, we can alter the values. And when I say value, specifically alter the inputs. What I mean by that is how much is total cost if I have 1 topping, 2 topping, 3 topping, those kind of situation. So when it comes to table, here's what we're going to do. Let's create 2 columns or row. It really doesn't matter whether you put it or not as a vertical or horizontal, but Why don't we go vertical? X basically represent number of toppings. Y is how much its total cost. And the unit is dollar. Now we can use the clue that is given up there, and then we can add things one by one. If we have no topping, then we only need to consider $9 and plus $0, which is total $9. That's my one coordinates. What if we have one topping? Well, the question says extra topping costs $1 per topping. So that means it's 9 plus 1, which is total $10. That's another data. Second, what if we have two topping? Then it's actually $9 plus $2, $11. Once you find a certain pattern, generally I put the numbers about 2-3 values to evaluate my output values. You notice that each X row, we are increasing everything by 1. But when you look at my Y values from row to row, you also notice that it's increased by $1 every time. Then we can predict, let's go 3 and 4, so 5 total values. We can actually go through the next sequence and find out what will be the value even without the substitution, even though substitution works the best. What's my next sequence? Well, you find a pattern that every row it is increased by $1. So you will have $12 for this, $13 for that. So long story short, we have a table. And then we can actually construct the table. As you may notice, everything is positive for the X value and positive for Y value. We just need to focus on quadrant 1. Quadrant 1, ladies and gentlemen. And let's create the graph. As you may notice, I put just a quadrant 1 over here, which is Y, you're going positive, X, you're going a positive. It is a good idea to put your X-axis instead of X. We actually can put a certain real-life application for X-axis, which is my left column, and I named it as number topping. On the Y part, this is what you need to do, folks. Can you see that I changed the orientation so that Y-axis become horizontal? You really need to pay attention for this, so that X-axis and Y-axis have its own orientation, different orientation. But long story short, Y-axis, instead of you putting it Y, you have total cost. And we're going to put these coordinates. The first coordinate is 0 and 9. So I like to put $10 ticks, 0 and 9, located over here. This is another 10. You can do it using your own way. 1, 2, 3, 4, 5. We already have our first coordinates 0 and 9, so have that in your mind. The next one is 1 and 10 over here. Second one is 2 and 11, 3 and 12, 4 and 13. I believe that's what we put so far for the values of table. And ladies and gentlemen, this shows that every value to value, can you see that I am increasing everything by 1? And that is evident when you look at the X column, it's increased by 1. And when you look at the Y, if I look at first point to the second point, can you see that from the first one, it used to be 9. Second one, it's going up by 1, 10. It also happened over here, also happened over here, also happened over here. So, long story short, this is a good example of linear relation because both X value and Y values are increasing evenly. And when I say evenly, that's like consistently. That's something that you may need to recall. Let's go to the next example. The question says, the graph shows the total cost in relation to the number of baseball you buy. Describe patterns you see on the graph. Make a table of value from the graph. And if the relationship continue, what is the cost of 14 baseballs? So we are dealing with the situation, ladies and gentlemen, where we're looking at, it's kind of like going backward. The previous one was, we know certain condition, and then we are transforming that or converting that pattern to the table. Then from the table, we construct the graph. We are going to do the opposite if the graph is given. We start from the graph, make a table, and we are going to find a condition or pattern that's happening inside of the table. Or in this case, the total cost and number of baseball. So first thing first, I'm going to highlight two type of condition in here. Total cost in relation to the number of baseball. And fortunately, we have our, how can I say, variable that is given as a graph over here. The cost seems like instead of y, you're using c. So this is almost equal to y. And instead of x, it seems like the question used b. So from now on, I'm going to call, instead of y is equal to something x, you may notice vertical axis y is represented by c, total cost. So I'm going to use the word c. On the other hand, when it comes to number of baseball, which is like an x-axis, horizontal one, instead of x, I'm going to put it as b. So what I'm going to put for, before we getting into it, let's do the table part first. I'm going to change up some of the orders. I want you to put whatever x-axis on the left side, in this case, b, for the number of baseball. Then c, which is the total cost. In this way, we are putting every coordinate's position to each of the row over here. Like if I look at each of the dot place, it's a good idea to put the coordinate for each of them, ladies and gentlemen. It go right by 1, that's positive 1 for the x. Second one 2, third one 3, fourth one 4. Quite self-explanatory when it comes to y position. 1 and it's between 2 and 4, it's exact halfway, so that's 3, 6, 10, 12. So, oh, sorry, that's not 10, that's actually 9. It's actually 8 and 10 between. So once you figure out these coordinates, you're going to put it for each row. 1 and 3, that's one of the value. 2 and 6, that's one of the value. 3 and 9, that's one of the value. 4 and 12, that's another one of the value. So I have a table. The table that show B, the number of baseball, as an X, except it's represented by B. That's my manipulative variable. which is like an X for you. And C, cost, dollar, and that work like responding variable, which is like Y in the world of math. So let's figure out the pattern. So first of all, we create the table, B's check. How can we find out the pattern? Well, whenever you try to find out the pattern, that's a fancy way of saying what's happening for input and what's happening for your output. Which is a fancy way of saying what's happening from here to there. What's happening for here to here, here to here, here to here, left to right. And generally, you need to think about some kind of operation. Is that addition going on? Is that subtraction going on? Is that multiplication going on? Or is it division going on? Any of those can be one of the pattern in the relationship between one side of the data to another side of the data. Well, as you may notice, the small number become bigger. So, it must not be a subtraction or division. Because think about it. If something is subtracted or divided, then the right value will go smaller, not going to be bigger. On the other hand, if it's adding or multiplying, we got to check. If it's adding, it's plus 2. But if I look at it, the below one, 2 to 6, that's plus 4. There's no consistency. I want you to look at multiplication. How come 1 turning into 3? Well, by multiply by 3, right? Does this rule apply equally for the second one? Yes, we do. 2 times 3 turning into 6. If you look at the same thing for the third one, 3 to 9, that's also multiplied by 3. And 4 to 12, that's also multiplied by 3. So the pattern that you can think of in this situation is every row is multiplied by 3. So with this scenario, you can say that every baseball cost $3 per each. You can think it in that way. In this way, it explains about this multiply by 3. If I buy 2 baseball, 3 times 2, that's 6. 3 baseball, 3 times 3, that's 9. 4 baseball times 3, 12. It's easy as that. Something like that. Now, let's do our C portion. If the relationship continue, what will be the cost of 14 baseball? Well, our answer A actually help you answer C because each baseball costs $3. So if I have 14 baseball, you just need to multiply 14 by 3, which is technically 14 plus 14 plus 14 if you like to do using addition. But in any way, 14 times 3, you can use this way. 4 times 3, that's 12. 3 times 1, that's 3. But 3 plus 1, that's 4. So long story short, $42 is how much it costs for. Is how much it will cost if you buy 14 baseballs. That's what I wanted to tell you. So, let's do the other one. Today's lesson is a bit heavy because, as you may notice, it involved lots of word problem. I believe for today, this is my last one. It's similar as a previous situation. The graph shows Nicole's rate of play based on the number of hours that she worked at a part-time job. And we have our graphs going on in here. We need to describe the pattern. We need to make a table. We need to make We need to find out Nicole's hourly rate of pay. There's lots of going on. But whenever there's a graph happening, then please understand, change this graph into table and find a pattern. And it is improv, to be fair. You need to go through each of a different situation, one by one. But let's highlight two variables that play a huge role. The question says Nicole's rate of pay. This will be either X or Y. We're going to discover that later based on the number of hours. But when I look at this relationship, do you agree that depends on number of hours, Nicole's payment change? So that means number of hours, it's like an X. You're changing that input. And what you will observe is how much your paycheck will be. That means number of hours better be horizontal, rate of pay better be vertical. Let's double check. As you may see, payment, it's like my y-axis. It is what we observe as a final. Then what is the manipulative variable, the one that changed? Number of hours, which is time over here. So time is like X. That means X is always on the left side, and the Y is always right side of the table. Let's go through that one first. Time on the left, and then payment on the right. Before you put any value in, if you have dots given, good idea to put coordinates position. 1, go by 1 to the right, 10 to the up. So that's 1, 10. Second value, 2 to the right, 20 to up, positive 2, positive 20. Same thing for the others. And these values are the one that should be putting in for each row. 110, it's 110, done. 220, done. 330, done. 440, done. So we have a table. It's a good idea to put some unit. Hour was the time, payment was dollar. Note the fact that this is like my Y, this is like my X. So, first thing first, we actually did C first, make a table, done. We gotta find out the patterns now. How can we find the pattern? Compare left to right. What happened between T to P, T to P, T to P, and T to P. And it is our job to figuring out, is that addition going on? Is that subtraction, multiplication, division? As you may notice, small numbers changing into bigger numbers. So you know what? There's no way it's going to be subtraction or division. It can be either adding or subtracting. But we need to pick something that is consistent. Consistent pattern. And when I say consistent pattern is, if I look addition, 1 to 10, you're increasing everything by 9. Plus 9 is what's happening from left to right. Does that similarly occur for the second one? No, it's not. 2 to 20, I gotta add 18 to 2 to make 20. So plus 9 plus 18, that ain't consistent pattern. So it must be multiplication again. How can we know? 1 to 10, how can you make it? Well, if you multiply by 10, you can make 1 to 10. What about 2? 2 to 20. You can do the same thing. Multiply by 10. 3 to 30. Same thing. Multiply by 10. Multiply by 10. As you may notice, we have a consistent pattern going on throughout the whole thing, ladies and gentlemen. So, I can conclude now that the pattern A is every hour Nicole receives typo over here, $10. That is my pattern. Each hours, so regardless of 3, 4, we can even predict what's gonna happen if she works 7 hours. Then she will get $70. That is my pattern. So A is also done. Describe the pattern. What is Nicole's hourly rate? It is specifically asking about the rate, so you put A into mathematical symbol. $10 per 1 hour. Easy as that. At least rate, we learned about that before. Is it possible to have points between ones on the graph? So D is an interesting question. Is it possible to have points between the one? I like to say for D, no, it is not, because her wage increases every 1 hour, not 0.5 hour. What I mean by that is because her working rate is $10 per 1 hour, so that means, and as you can see from these grid over here, everything is increased by 10 for each of the row, and when it comes to time, it's increased by 1. And the time system work as each of the one, like 2 hour, 5 hour, not 4.5 hours, something like that. So the thing is, when it comes to this pattern, you don't put any of a dot in between the ones on the graph. You can just look at that as a pattern. However, in future, we're going to see that we're going to connect the line and then make a continuous graph because some of the value can lie between the data points. And that's my future discussion, however. Your homework, ladies and gentlemen, is actually given on page 11 over here. Your textbook page 337. I want you to do question number 4, 6, 8, and 10. I want you to give it a shot for this 4 questions.